settling in this part of your body. And when you look at most of us, that's where it is. And when this happens, not only is it making the skin stretch and we're showing we need larger clothes, etc., but all these organs are then getting infiltrated with fat material. Muscle fiber. This is going to be talked a little bit more tomorrow. I'm just kind of going through this quickly. Muscle fiber represents cells that are lined up side by side. These cells are moving. They're moving back and forth. And in order for them to move, there has to be energy molecules that can get in between them. There are enzymes that come in that help these muscle tissues do what they have to do. So there's space in between here on purpose. Put these cells side by side with space so that these molecules can get in there and help these cells do what they have to do. When your body is collecting fat, the fat gets in between here. And so what's happening is the molecules don't have so much space. Now, those enzymes, the enzymes are trying to get in. The energy molecules, they're called ATP. I'll go through that tomorrow in more detail. They're trying to get in. And as these molecules are trying to get in, they can't because the space is being filled with fat molecules. The muscle fiber gets weaker and weaker. Once a person starts developing excess fat in their body, they actually have a lower level of energy available for them to do work. So they exercise less. And they're still eating. And they're not exercising. And the cycle just goes on until you get even more fat in here. And it's even harder and harder for the muscle to do its work. Now I said muscles. There's one of them right here that's very susceptible to this. And that's the heart muscle. And if it starts losing its efficiency, then the cells are going to be losing that. And if the cells don't have oxygen, I don't care how much glucose you eat, you're not getting any energy. Because there are two things in our bodies that give us energy. And that's glucose acting with oxygen. And if you don't have both of these present at the same time, you're not going to have energy released so that you can do the things that you have to do. How do we get the oxygen? We inhale. The oxygen goes into our lungs. The lungs then sends the oxygen into our blood vessels that go to the heart. The heart picks up the oxygen, and the oxygen is sent through the blood from the heart to the rest of the body. If the heart muscle gets infiltrated with fat, you're not getting a lot of this. You can eat all the candy bars, drink all the energy drinks you want. It's not going to do you any good. So this cycle of things working together is something you're going to see throughout my talk for the next couple of days. And the pancreas of this person, once it's been forced to produce extra insulin more and more and more and more and more, and there's no signal to say, hey, slow down, slow down, slow down, because the glucose is not getting where it needs to be, this pancreas gives out. And next thing you know, the person's got type 2 diabetes. If the pancreas is still functioning a little bit, they will be able to produce a little bit of insulin. But if it stops functioning altogether, now they need total insulin every day, every single day. They don't have a choice. Otherwise, they will die prematurely.
As with type 1 diabetes, the symptoms of type 2 diabetes are going to the toilet a lot, thirst, thrush or genital itching, slow healing of wounds, blurred vision, tiredness, and weight loss in some people. The symptoms for type 2 diabetes come along very slowly, and some people don't have any symptoms at all. So for that reason, people can live with type 2 diabetes for up to 10 years before they realise that they have it. Type 2 diabetes can be treated in a number of different ways. Initially, it may be sufficient to make changes to the food you're eating, undertake extra physical activity, or lose any weight that may be appropriate. But type 2 diabetes is a progressive condition, and most people will need some form of medication to treat it.
Okay, that's one disorder. Now, if you notice with type 2 diabetes, they said that, you know, one of the things that happens is that you have this fat building up around the cells. That doesn't happen at birth. That happens over time. And so if you think back to the people that, if you think back to the individuals that you were counting when you were filling out your cards, can anybody think of someone with diabetes that had diabetes as a child and they say that it's type 2? Anybody in this room? Know anybody that had diabetes type 2 as a child? That is not the norm. That's a lifestyle disease. It's a disorder that comes because of the lifestyle of the person. So, okay, I don't mind having diabetes. Hey, I just take my insulin. I'm not scared of needles. I don't mind sticking myself every day. I can do this. It's okay. I'm still going to live a functioning life. I'm going to be okay. Diabetes doesn't just affect your energy level. It affects other things. Our kidneys serve as a filtering device.
Kidneys are bean-shaped organs which filter blood to regulate levels of waste, water, and salt in body fluids. The nephron is the kidney's functional unit.
The nephron is like a series of pipes. It's hollow in the center. It has cells surrounding it on the outside. The fiber is like, I don't know if you've ever seen angel hair pasta, where it's real thin, and when it's cooked, it's real flimsy and very easy to break. Well, that's basically the structure of nephrons. And nephrons are in it. There are just thousands of them packed into those two bean-shaped structures that we call our kidneys. And inside, like I said, it's hollow. So the blood coming from the cells with the waste inside of it. Just think about the power of Allah when you think about how this system is so intricate and how sensitive it is to different things. And how he even regulates so that even that sensitivity doesn't create a serious problem for us. We'll see more of that as we move through. But the nephrons are all piled into these two kidneys. And as the blood leaves the cells, the blood has in it stuff. It has waste, it has good stuff, and it has bad stuff. Well, the blood is sent to the kidneys through two narrow pathways, one going into each kidney. And the blood then gets passed through these nephrons, and as it's passing through, the larger substances stay inside of the pathway, the smaller substances come out. They're pores to allow certain things to come out. So here's the blood coming in. Those two loops on the left side, those are the blood vessels, and they send the blood in, and see inside the blood, you see the large yellow pieces, the reddish-orange pieces. They're going to go through this pathway. And some of what's in there is going to be filtered out and go down the pathway into the next section. And this is happening every day, all day long.
Filtrate within Bowman's capsule enters the proximal convoluted tubule. Reabsorption of important molecules and ions from filtrate back into the blood occurs here. These include glucose, amino acids, vitamins, water, sodium, chloride, bicarbonate, and potassium.
Get back to that. All right. So these substances that they have the names for, they've left this pathway. They've passed through some tiny pores, and they've left out of the fluid that came from the cells. And they're going back to the body, so the body can use them. So the amino acids actually become part of proteins. We'll deal with that tomorrow. Vitamins are examples of proteins. We'll deal with that tomorrow. Amino acids, vitamins, and glucose are huge as far as structure goes. They've got a lot of atoms bonded together to make large structures, large molecules. We actually call them macromolecules. Water